Hello everyone, welcome back to Chemical Engineering and Aspen channel. As you know, these days we are focusing on the module of heat transfer operations. So in this regard, we are bringing the lecture number 15 for our valuable viewers. In the previous videos, in the previous lectures, we have discussed the different types of heat transfer which includes conduction, convection and radiation. We studied the different laws which include Fourier's law of heat conduction, Newton's law of cooling, Kirchhoff's law, and then we move to the heat exchangers in which we studied the various type of heat exchangers which include the double pipe heat exchanger, shell and tube heat exchanger, plate and frame heat exchanger. Now today we will be solving a numerical problem related to the heat exchanger. There are basically two problems which includes the steam condensation and heating water in counterflow heat exchanger. But today we will be solving the example number 1, and in our next lecture, which is lecture number 16 on the heat transfer topic, we will solve the example number 2. So before starting the video, if you have not subscribed to the channel yet, please subscribe to the channel. Click on the bell icon to get all updates related to this channel. So today we will be solving the example number 1, which is steam condensation in a condenser. And the problem statement is that the steam in the condenser of a power plant is to be condensed at a temperature of 30 degrees centigrade with cooling water from a nearby lake which enters the tube of the condenser at 14 degrees centigrade and leaves at 22 degrees centigrade. So we know the steam which is entering in the condenser at 30 degrees centigrade. We know the cooling water, the cooling media is cooling water in the system, or the cold stream is cooling water, the hot stream is steam, and the inlet temperature of the cooling water is 14 degrees centigrade and the outlet temperature is 22 degrees centigrade. The surface area of the tubes is 45 square meters. So we have been given the information about the value A, and the overall heat transfer coefficient, which is represented as U, is 2100 watt per square meter per Kelvin. So this is the problem statement in which we are given the information about the temperature, we are given the information about the area, and we are given the information about the U. Now the question is that we have to determine the mass flow rate of the cooling water which is required and the rate of condensation of steam in the condenser. So we have to calculate the two parameters. Number one is the mass flow rate of the cooling water, and number two, the rate of condensation of steam. So this is our problem statement. Going to the assumptions part, but before going to that, if we look at the pictorial representation that the steam is entering at 30 degrees centigrade and leaving at 30 degrees centigrade, while the cooling water is entering at 14 degrees centigrade and leaving at 22 degrees centigrade. This steam is converted into saturated liquid. So this is the liquid temperature and this is the steam temperature. So there are 5 assumptions which we have to take while solving this example. Number 1 is that we will assume that the steady state operating conditions exist in the system. Because once we talk about the unsteady state system, then the equations changes and the system becomes a bit complex. Number 2 is that the heat exchanger is well insulated, so the heat transfer or the heat loss to the surroundings or to the environment is negligible. Number 3 is that the changes in kinetic and potential energies of the fluid streams are negligible. There is no fouling in the heat exchanger and fluid properties remain constant throughout this system. So these are the 5 well-defined assumptions which we will take, and these assumptions will help us in simplifying our problem statement. Going to the properties part, we will assume that the heat of vaporization of water at 30 degrees centigrade is 2431 kilojoule per kg, and the specific heat of cold water, which is at the average temperature of 18 degrees centigrade. If you see, the inlet temperature of the cooling water is 14, the outlet temperature is 22 degrees centigrade. So the average of it will be 18 degrees centigrade, and the value of Cp is 4184 joule per kg per Kelvin, or we usually pronounce it as 4.18 kilojoule per kg Kelvin. So these are the two properties which we will consume, and as we have discussed in assumptions that these will remain constant in the system. So the first part is the calculation of LMTD followed by the calculation of Q. Now for the calculation of LMTD, the formula of LMTD is delta T LM is equal to delta T1 minus delta T2 divided by natural log of delta T1 divided by delta T2. So first we need to calculate the delta T's. How these can be calculated? Delta T1 is equal to temperature of hot at inlet minus temperature of cold at outlet. So we know hot stream is the steam, temperature is 30 degrees centigrade. Cold stream is cooling water, its outlet temperature is 22 degrees centigrade. 30 minus 22 comes out to be 8 degrees centigrade. Then delta T2 is equal to T hot out, which is 30 degrees centigrade in our system because it is saturated liquid, minus T cold in, which is 14 degrees centigrade coming from the nearby lake. So the answer will be 16 degrees centigrade. So substituting the values 8 minus 16 divided by natural log of 8 divided by 16, the answer comes out to be 11.5 degrees centigrade. Accordingly, Q is calculated as UAS delta TLM. Now the value of U is 2100 watt per square meter per Kelvin. That is given in the problem statement. The value of area again given in the problem statement as 45 square meters. And the delta TLM, which is the log mean temperature difference, which is now calculated as 11.5 degrees centigrade. So the answer comes out to be 1087 kilowatt, which is the rate of condensation in the condenser. So this is the first part which we have calculated. First we calculated the LMTD and then we calculated the Q based on the provided data. Step number 2 is to calculate the mass flow rate of the cooling water, and we know that Q is equal to mCp dt, while m represents the mass flow rate of cooling water. Cp is the specific heat capacity of the cold stream. T out is the outlet temperature. T in inlet temperature, we know T out, we know T in, we know the value of Cp. There are two unknowns, mass flow rate and Q. But if you see, once we talk about the heat exchanger, the amount of heat transferred from the hot side is equal to the amount of heat gained by the cold side. So that Q is equal to 1087 kilowatt or kilojoule per second. Rearranging the equation, Q is equal to mCp dt or Q is equal to mCp T out minus T in. It will become M is equal to Q over Cp T out minus T in. So Q value is 1087 kilojoule per second. Cp is 4.184 kilojoule per kg Kelvin. T out 22 degrees centigrade, T in 14 degrees centigrade, and accordingly the answer comes out to be 32.5 kg per second. So the 32.5 kilogram per second of the cooling water is required to process or to convert or to condense the steam into the saturated liquid. If we want to calculate the amount of steam which is fed in the system, that is equal to Q over HFG, which is the heat of vaporization. So Q is 1087 kilojoule per second, and the heat of vaporization value, which we assumed to be constant throughout the system at the given conditions, is 2431 kilojoule per kg. Accordingly, we get the answer as 0.45 kg per second. So this is the amount of steam which is required in the system, and this is the amount of cooling water which is required in the system, or you can say this is the amount of steam for which this much cooling water is required in the system. We can say we need to circulate about 72 kg of cooling water for each 1 kg of steam condensing to remove the heat released during the condensation process. So this is the detailed description of the heat transfer or the heat exchanger operation in today's lecture. So I hope you have understood all the aspects of this lecture. If you have any queries, feedback, suggestion, please provide it in the comment box and I would be happy to answer it. So that's it from today's lecture. Thank you so much. Please do watch, like, share the video and subscribe to the channel. Also click on the bell icon to get all updates related to this channel. Till then, it's goodbye. Stay tuned for more exciting videos on this channel.